Got the green light. All right, well, hey, welcome everybody. My name is Brennan Smith-Elliott. I'm a VP of product here at Arcadia. We're going to be talking about large language models, that newest buzzword term, the newest three-letter acronym in healthcare, and its use cases and how you can fine-tune it and drive success. So this is going to go pretty high level and talk about some technical terms. We're going to go deep into how to think about some of these concepts within healthcare, about biases, about the kind of pitfalls that you may run into, and give you kind of a general framing for how to think about it. So, what's so challenging about the use of large language models within healthcare? Well, there's four key things that we're going to talk about today. The first is that they're pretty hard to tune. A large language model is this giant neural net, this giant sea of facts, this graph of facts, weights in between those facts. And most of the models that are built today for general purpose have healthcare knowledge, but they also have a sea of outside knowledge that influences that information. That includes things like biases, that includes consumer behaviors, all kinds of other facts and knowledge that can interweave with that information. So you may be able to use these models for healthcare use cases, but if you don't tune them, if you don't adjust them, you'll see all kinds of bleed, all kinds of other information that gets into the output. That leads into the next thing to think about, which is unpredictable results. So with large language models, they're getting constantly tuned, revised. A lot of the ones that come out of the box have new information injected into them all the time. That results in a drift of the information. So in traditional healthcare AI and ML, you're able to adjust for that drift because you're in control of the data. With large language models, if you're using some of the large commercial ones, there's an additional dimension of drift as that information changes, that knowledge changes in the large language model itself. The third thing to think about is they are most powerful with additional data. The more context you can give them, the more information that you can give them, the more accurate, the more precise the output. A lot of the models, it's challenging to inject that level of data out of the box. So you have to think about strategies and tactics to take to ensure that the context is appropriate for your use case. Last thing I'll note is that they are improved with feedback. So if you build in a cycle into your use of the model, if you build in a virtuous loop, you're able to take user feedback, you're able to take users' actions, even something as simple as a thumbs up, and improve the outcome, improve the results over time. It's critical to think about that loop, that feedback loop, as part of your design and use of the large language model. So what does this bring us to? Well, if you're in healthcare, we love using old concepts. One of my favorite concepts is continuous quality improvement. Plan, do, study, act. Works perfectly well with large language models. We're going to talk about what each of these phases might look like as you implement a large language model, but it's perfectly acceptable. It's perfectly a great framework to think about implementation. So when you're planning, think about something like a prioritization framework. What are the jobs that you can automate? What are the opportunities that you have in your ecosystem? With each of those opportunities, think about how ready your data is. Is the data available? Is it clean? Is it trusted? Is it aggregated? Is it actionable? You need to make sure that the information that you're going to feed the model is accurate and actionable, else you're just going to get garbage results. Now, large language models, deep learning, can be used for data discovery, for understanding anomalies in your data, understanding aberrances, but if you're feeding end use cases, you need to make sure that that's enough of a high data quality for it to be actionable. So think about ranking that from 1 to 10, where 10 would be high quality, very actionable data, 1 is not actionable. Then, what is user trust in AI? I'm going to give a personal anecdote. One of the biggest failures I've had in my career was trying to convince a doctor to order something differently with a sepsis prediction algorithm. And that's not because of the predictive accuracy of the result, but because of the user's trust in the outcome. You have to have an opportunity to influence their behavior, to change their minds, whether that's the patient, the doctor, the payer, whoever is in that continuum of care, and they have to have some kind of trust in that result. Now, there are influencers, there's ways that you can build trust in your end users, but given the current state of healthcare, there are certain use cases that have sensitivities you just need to be aware of. So think about scoring that, where 1 might be low trust in that particular use case, 10 might be something that's easy to change. Then what is the relative infrastructure cost? With any large language model, we say language, right? You think about text, you think about structured data, but a lot of these models are actually multimodal now. But with multimodal, taking in video, audio, pictures, that increases the infrastructure cost. That increases the cost of maintaining the data, of streaming that data, of compute, and it increases your cost there. And then finally, think about the existing adoption of behavioral levers. Where do we have clinical decision support today? Where do we have interfaces, applications that are readily accepted, readily adopted, that you can plug your automation into? So in that case, a 1 might be something that would be completely novel use case, a completely novel behavioral lever. A 10 would be something like a chatbot that the patient is already interacting with for care coordination. Once you have all that ranking, multiply it together, and that gives you a relative weight of your opportunity. You can then take those various opportunities and evaluate which ones you want to take action on first. We'll talk about that in a little bit more detail in a second, but once you have that key opportunity, experiment. Figure out what makes sense. Figure out what the output looks like with freely available GPT or Gemini. And then build experimental frameworks that would generate both qualitative and quantitative feedback. What that looks like is something where you might take like an existing chat interface and have your care coordinators use ChatGPT to get an expected result. Have them copy and paste that in and then give feedback on that. So there's all kinds of opportunities that you have within these use cases to do kind of what we call a Wizard of Oz approach behind the scenes of changing the output, changing kind of the interaction model to understand whether or not you have an influence there. Then, I'm going to throw out acronyms, and of course it's healthcare. We've gone from 3-letter acronyms to 4-letter acronyms. So reinforcement learning from human feedback is a big part of success within LLMs in healthcare. You need some kind of feedback loop to ensure that the output is accurate and actionable. So with your first use cases where you're generating that example output, think about opportunities to get feedback from a clinician, feedback from an end user about what they would expect. So one of the most powerful aspects of large language models is that you can take the output, ask the clinician and say, hey, if you were to see this output and you were to actually write this up, what would it look like? Have them write that example, and with about 50 different examples per use case, you can actually dramatically change the output of the model. It's something called few-shot learning to be able to do that adjustment. And then finally, think about how you can combine those curated responses together within your model. Now, what that looks like, you may drive like a human prompt or response with some chart data, some patient information data that's de-identified. Here we're saying, hey, you're a doctor, you're a PCP in Orlando, you're trying to determine what's happened to the patient since a certain date. One thing that's important to note about here and think about with prompt engineering is how you can inject a little bit of structured data into that prompt to give it even more contextual information, even more powerful information, so that it can drive to a much more narrow result. And then we're asking it to summarize what are the key clinical indicators within the chronic diseases, cite source data. That's the kind of color information that you want to put in there to establish trust with the use case and the user. And then format, use a bulleted list, speak in a professional tone. Now, if you do that, you might see some weird results. So one of the things that we got as one of our use cases was a comment from the LLM about the patient's height. That's interesting. The patient didn't grow. The patient didn't shrink. They're 50 years old. That's probably not going to happen too often, right? So that's the kind of thing that you want to suppress. That's the kind of thing that will erode user trust. And the way to do that is, again, you can use few-shot learning, where you can have the clinician say, I would never say that, delete that out of every result, feed that back into the large language model to tune it so that when it spits out the result again, it's not going to include that result. That's one opportunity, and we're going to talk about another way to address that. The next is when you're thinking about expert review and reinforcement learning. So we just talked about one approach, which is called few-shot learning, where you can take about 50 different corrections, push that into the large language model to have it be more accurate. The next factor here is expert review and reinforcement learning. Once you have that tuned model, once you have it adjusted, you can go through and rank the results. And what that gives the model is an understanding of the priority, the weight, the relative weight of the output. Again, it's important to have clinicians, it's important to have nursing input, folks that are relevant to the use case, provide that feedback to you, provide that stack ranking so that they're able to adjust it accordingly. And then as you kind of develop this, you stack rank it, you feedback it into the machine, repeat this until variance is very little and you're really happy and satisfied with the result. Lastly, ensure that there's a way to gather user feedback. This needs to be included from the forefront, either qualitative or quantitative feedback. If it's something like CDS, where you're providing suggestions to the end user, you usually have a very structured form of input, a structured data point to be able to gather. Or if it's something a little bit more qualitative, like we're giving the patient some feedback and they're working through a chatbot-like interface, did they close the chatbot interface after seeing 1 or 2 results? Looking at timing, looking at product adoption as key pieces of data to then feed back into your model. So again, very important to capture that data up front and to think about how to building that in. Again, something as simple as a thumbs up button is really powerful information to then feed back into your model. Another approach here is to audit the output, kind of in a randomized trial. This helps you to evaluate the output, and if there's some random results that are creeping in that maybe didn't show up in your other kind of product analytics, there may be some clinical factors there that are leaking in. It gives you the opportunity to correct that. Then again, we talked about thumbs up, thumbs down, and flag dead-end responses. So a dead-end response would be something where there's a chatbot interface and the user all of a sudden abandoned the chat. That kind of dead end is really important to track because it tells you that the user is disengaged from the output. Again, chatbot's a common example there. Another example would be something like the summary is streaming on the screen. Did they close the button as the summary was streaming? You need to have a data trail, a breadcrumb trail to identify those disconnects so you can have an opportunity to go in and correct it. Thank you, Alex Dim, for this diagram. So it looks roughly something like this in the final result, where you're taking that text data, you're taking that input, you're training your model, and then you're going through and kind of freezing the result with what's called a reward model to correct that, weight the results based off of clinical input. And then finally, with reinforcement learning, constantly update the model. So this gives you a super powerful approach to use in healthcare, primarily because the reward model approach weights clinical input, weights expert input into the end result, which is extremely necessary for healthcare. If you don't do something like this, you're not necessarily going to build in expert think or clinical think, and your end result gets fuzzy, it gets sloppy, and you don't build in a cycle over time to be able to correct that. I could go into detail about any one of these boxes for many, many more minutes, but I'm just going to keep this high level. The other thing I'll note is that both the reward step and that fine-tuning step for training give you a really good opportunity to de-bias the results, which is extremely important in healthcare, as we all know. And having a process that includes a blind review, a blind label by that expert panel helps you to ensure that the results are not getting skewed by any kind of external factors. Very important with large language models. So to wrap this up, thinking about time to complete as a really good outcome to monitor. So once you have that all in place, monitor outcome metrics, understand whether or not you've made an impact on the end user. Think about how you can improve patient management and how you can take a workflow and simplify it. So if you're adding additional steps, if you're forcing the user to give you feedback, if you're introducing some extra clicks, you're not actually helping the user. So make sure it's nice and simple and you're not causing disruption.